My name is Ihor. I'm here with Song. We are from Meta's kernel team, more specifically BPF. And today we're going to talk about Kernel Patches Daemon, which is a piece of software that was developed here at Meta to help with BPF subsystem testing infrastructure. And so what is it? Kernel Patches Daemon is a service or daemon written in Python, and its main job is to connect Patchwork and GitHub. Why was that necessary in the first place? Is to leverage GitHub Actions for testing of the incoming patches. So it was, as I already mentioned, originally developed for BPF CI, and it's still in use, of course. And how I will talk in more details about how it works. But you, of course, need to, in order to use it, you need to run it on a server somewhere. It is open source. I believe it was open source very soon after it started the project, but due to Meta policy, it required contributor license agreement signed. But recently, because there were requests to do that, we got rid of it, and now you can just use it and contribute to it if you want. Without any additional permission. So how does KPD connect Patchwork and GitHub? Basically, it tries to keep in sync pull requests on GitHub with patch series on Patchwork. And it would pull requests from Patchwork, patch series from Patchwork, and open and update pull requests on GitHub. And of course, GitHub Actions are usually triggered by various events in GitHub repository, which is, a separate topic, and KPD does not directly implement any testing, right? It's just serves as a trigger for GitHub Actions depending on events on Patchwork. So how does it work? What are the components? So it obviously needs to talk to Patchwork to be able to not only request data for because read-only access, I believe, is available without any keys. By the way, KPD can run in read-only mode, although it would disable some of the features it has. But it also updates checks. I believe it's called status checks on Patchwork, depending on the results of testing on GitHub Actions. So on the one side is Patchwork, on the other side is GitHub. And it uses GitHub Python client to talk to GitHub. So we need kernel. You need GitHub org or some kind of user to have an API key to manage the repository, and you need a key to talk to Patchwork. And Patchwork, of course, is also another piece of software that is monitoring mailing list to create patch series, and it has web UI and everything. And I hear many maintainers prefer to use it for to help them manage the incoming traffic of patches. One of the reasons why this BPF CI thing was important is because there is quite a lot of patches coming in, and all this setup with KPD and automated testing helps to test the patches even before they are reviewed, right? As soon as they pop up on patchwork, they already, like very shortly, they run the default testing on GitHub, and the results are immediately visible both to the author and maintainers. So yeah, I didn't mention all the pieces. So you obviously have an upstream repository for your subsystem, which would usually be hosted on gitkernel.org. And you have a mirror of this repository on GitHub in order to enable the testing that KPD is doing. So KPD is keeping in sync the repository upstream, which you of course can configure, with your repository specifically for testing. And excuse me, another piece that you need is the CI repository, which only contains the code related for your testing. So it would be like .github directory with all the scripts and YAML files to configure GitHub Actions. And in order to, like how GitHub Actions works, in order to trigger the testing in your repository, that .github directory needs to be in your repository. However, we don't want to, we want this mirror of the upstream repository to have very close, well, ideally identical history with the upstream repository. And what KPD does is whenever there is an update upstream, it force pushes to so-called base branches in KPD's terminology to the Git repository, and on top of it, it adds a commit that simply copies the contents of CI repository to target repository that is going to be tested. So this is why you need to separate like your repository on GitHub and CI stuff. Yeah, this is in a little bit more detail. What does it do? So KPD runs on some server. It clones your mirror GitHub repository. It asks GitHub for all the open pull requests. Then it asks patchwork to for recent patch series. I believe you can configure it with like how long in the past you want to check for the series. It could be like 1 week or 1 month, depending on traffic on your mailing list. You might want to increase it or decrease it. Then one tricky thing that KPD is trying to do is to parse tags and like parse the subject of patch series to figure out the appropriate tags for or I should say labels for Git and for pull requests, and also to know like when a new version of the patch was posted on the mailing list, so that on the GitHub side the same pull request is updated. It's not always easy. We had I remember there were cases when somebody sent a patch with empty subject and KPD just crashed. But you know, these kinds of things can be fixed, right? And like in most cases, it works fine. Then KPD tries to apply the patch locally, and if it's not successful, it would update the check on patchwork with merge conflict, and also on GitHub side, the pull request will get merge conflict label, which is also useful, of course. If applying patch was successful, pull request is updated, which triggers the CI, and then later KPD would look at the checks status on GitHub through the GitHub API and post that information back to patchwork. So this is how it looks on GitHub side. If you open your repository on GitHub, which is a mirror of your upstream, and you have all these open pull requests. And as you can see, there are various labels like, what is the target upstream, like BPF next or BPF, for example. That this is a new series and this is version 2 and CI testing passed for it, and so on. One cool thing about this setup with GitHub Actions is that developers are able to open a pull request on GitHub manually by themselves. So like they can create a fork of your repository, make some changes, post a pull request at this repository, and then your CI testing would run for that change, right? So this way developers can test their changes even before they post them to the mailing list. Of course, you can, depending on rules of your org, you might not want to random people to open pull requests, and there are different ways. It's more of a GitHub thing. You can configure to approve some of the pull requests, or you can forbid it altogether. It really depends on your perspective, right? And on the patchwork side, for every job, basically, KPD would post a check. It's not very nicely named, but for example, on the name on the right, you could see this is a name constructed by GitHub Actions job, right? It depends on how you write your YAML files, what the text here is. But as an example, in BPF, like GCC 14 would be the compiler that was used to build the kernel. And various test names are test runners that were run, things like that. So just very useful to get an overview. In some, you could say that this is duplicate between GitHub and Patchwork, but it's just a matter of preference, given that, I mean, like as a user, you could look at the results here, or you could look at them on GitHub side. It doesn't really matter, right? But the function of KPD is to make sure you can make use of GitHub Actions, basically. So yeah, I guess I already touched on this, but why would you use it? Well, testing changes that are incoming upstream is, of course, a huge topic. That's why we are all here. And if you test the changes even before a maintainer looked at them, it's actually saves time, because first of all, if there is an error, the author of the patch would see it. Yeah, I didn't mention that KPD can send email notifications if you configure that. Which is, the whole point of it. And, the author of the patch can look at the logs and try to figure out what was wrong, right? It's not always simple, because on BPF side, for example, we are testing S390 architecture, and it's not always easy to reproduce an issue there, for example. But still, like you want to know if something broke, even in some configurations that maybe you as author of the patch don't care much about. But it's up to you to convince maintainers that it doesn't matter then, right? Yeah, so. And KPD itself is a relatively lightweight service. Like it's Python, so it's not particularly fast, but you don't need it to be fast, because most of the stuff that it does is cloning the sources and making network requests. So it doesn't do much of a compute, right? But I would imagine if the amount of patches incoming is very big, well, I don't know what would happen, right? But fortunately, there are not that many subsystems where the number of patches is huge, right? It may be a few of them. And they would probably not use KPD, I would guess. Yeah, I guess that's all from my side, and Song will talk a little bit about how would you set up KPD if you wanted to. Song?
Okay, next slide, please. Okay, so as we already talked, we need a patchwork. So basically, we look at the patchwork.kernel.org. You can see a lot of subsystems. In many cases, there's already a project for a subsystem on there. But if not, we need to create a project for a subsystem. Usually, the project connect to a mailing list or maybe more than one mailing list. And on the and that's the project we will see the patches. And then for KPD, we need a patchwork account. And we need the patchwork account to be the maintainer of the project before writing back the results to patchwork. And for both these steps, if we need help, we can email helpdesk@kernel.org. And they're very nice to set up things for existing mailing list. And then we need to create an API token for the KPD's account, and KPD daemon will use this, and we're going to show that later. And the next step is a bit tricky because for KPD use the project ID of your project, and it is not clear online from the normal view of Patchwork, but you can use this link to look up all the projects and find the link, the ID for your project. Next, please. Oops. Okay, so on the GitHub side, you will need to set up organizations with the set organization. And in this organization, we need a minimum 2 repositories. One is the Linux repository, where we have the PRs created and the test run. And the other is the CI repository, where we maintain all the GitHub actions. The separation gives us the flexibility to make changes at the CI repository while make the Linux repository relatively clean with only the history and with the history close to the upstream repository. After that, we need to create a GitHub app with this link. And this app acts as like a robot or something that do work with Patchwork account. And for this, we need to give certain permissions to the GitHub app. We are sure we need content, pull requests, and workflow. And recently, we see an issue with KPD that may require the issues permission. So if you see errors with KPD, maybe the permission issues is the missing piece of that. And similar to the Patchwork side, we need some private key for KPD to use because we are creating pull requests on behavior of this GitHub app. Then we need to install this app on your organization and give it access to the Linux repository. And for this, you need the app ID, which is the ID of the GitHub app, and installation ID, which is the installation of the app on your repository. And both of these are used by KPD later. And next page, please. Then we will need some tests in the CI repository. This is a snapshot of the CI repository like a couple days ago. And the key here is the .github workflows.yama files. And all the other files are used by the YAML files. The YAML file defines all the tests. We build the kernel, we run certain tests on it. And let's go to the next page for example of it. Okay, so this is a very, very basic test defined in the YAML file with the name, It's MyCI, and it's triggered on pull request, and it will start a bunch of jobs. The job is the first job we have is build the kernel, and we provide its runs on tag, which means which runner should use should be running this test. Here we have the Ubuntu latest, which is GitHub provided free runners under certain condition. I think there's a rate limit or something, but it's good enough to start with it. And for BPF, we have some more powerful runners, including the rare asset like S390 ones. And later we see their steps. There we'll check out the kernel with Git. And here, because it's the pull request, we already have KPD already applied the patches and signed the pull request. We just check out the whole pull request, and that's including the base kernel and patches. Then the next step is to build the kernel, and once this this will get started with testing your patches whether it builds. Next, please. So then we need a little server, and we see like 2 cores and 4 GB memory is more than enough. If we go smaller on memory, that we may get some issue with Git clone steps. And next, please. Okay, this is the config file we're going to use. You'll see that we have information about the patchwork, KPD, and consigned email, which is optional. So the second section in the email configuration. And later it's describe different branches and how we match patches to branches. And as you may know, BPF, we primarily tag patches in BPF, which is fixed for current release, and BPF next, which is features for the next merge window. So we have different tag, and below is the different branches, is the BPF, and it have the GitHub app ID, installation ID, private key, and everything we just described in previous slides. And next, please. Okay, yeah, that's everything we want to cover today. And this is GitHub, KPD on the GitHub. And there are some documents written by Luis that give more details and more figures about how you can start it, how you can start using KPD. So, any questions?
Yeah, I think a question I have is like, how many subsystems are using this? I know of BPF using this, but are there others using KPD nowadays?
We have people using it. Luis will enable that for kernel modules, kernel firmware, and a few. And I'm also using it for MD RAID, the software RAID subsystem. And a while back, we see RISC-V folks using it, but I'm not sure whether they are still using KPD or they implemented their something similar to KPD.
Yeah, so
These are the non-users. Oh, actually, well, a few months ago, someone said he's trying this for Linux block mail list.
the other thing too is that one of the complexities with this initial support was that you required a mailing list originally. Now, fortunately, we have convinced the kernel.org folks to also use Lay to allow you to have customized smaller subsets in case you don't have a specific mailing list. Like, so FSDevil, for instance, is pretty heavy traffic. So if you would test every patch that goes to FSDevil, it would be quite cumbersome for a small file system like proc or sysctl, for instance. So for those types of file systems, we essentially have advocated, unfortunately got support from kernel.org admins to essentially implement the lay-based implementation for patchwork. It does work, but unfortunately, we're still trying to figure out the issue and the bug that prevents usage with KPD. But yes, basically we're using KPD also for different subsystems, modules, firmware loader. sysETL is one of those examples of a pseudo file system where we want to get to that point where we can leverage this lay-based implementation from patchwork. The proof of concept right now that we're trying to get fixed is the firmware loader, but that hasn't yet been addressed. So this requires some investigation in KPD. So eventually, my hope is that I'll get some time to debug that.
Okay, thank you. And my understanding is that you'll be creating a bunch of branches as pull requests. So other CI systems like kernel CI, what branches they could be testing that as well, right?
Yeah, actually the default right now is it will create a pull request for every single set of commits. And as you guys, if you look at the documentation that's provided in KDOPS for KPD, you'll see that there's a series of hoops that you have to jump through to try to be paranoid in case you don't want to enable random people to be pushing random, merge requests to your tree and then instantiating some self-hosted runner type of workflows. So a future change there is basically to modify or allow KPD to give the option so that way instead of a pull request, it would actually do a branch. Because that by default is not allowed for all random people on the internet, right? Most repositories allow anyone on the internet to send a pull request.
Okay, thank you. I guess that's it. Well, thanks a lot for the presentation.
Thank you.
Thank you.